Assalamu alaikum everyone, my name is Yumna Hussain and welcome to my presentation. The title of my project is Statistical Analysis of SAT Scores by Year and Gender. In this project, I analyze SAT math score for male and female over a span of years using statistical concept and visualization. The SAT is a standardized test widely used for college admissions in the United States. This dataset provides math scores by gender from 1967 to 2001. My motivation for choosing this project was to explore trends and disparities in academic performance across genders using statistical methods. The objective of this project was to analyze these scores using descriptive statistics and data visualization to gain meaningful insights while exploring the differences and similarities between male and female performance. This dataset was sourced from Kaggle and it includes several columns such as SAT, Math, and Verbal Score for male and female and all students. For my analysis, I selected only three columns. The year column, which I converted to an index, and SAT Math score for males and females respectively. The dataset was already cleaned and didn't require extensive pre-processing apart from selecting the desired columns. I started my analysis with three central tendency measures: mean, mode, and median. For male, the mean score was approximately 524.03, while for female it was about 485.06. The median value closely matched the mean, showing consistency in dataset, and the mode for both genders indicated the most frequently occurring scores. Next, I calculated the variance and standard deviation to measure the spread of data. The variance for male score was around 36.26 and for female score it was 74.88, indicating slightly more variability in female scores. The standard deviation was 6.04 for males and 8.65 for females, confirming the male score were more consistent. I analyzed skewness of data to understand its symmetry. Both male and female scores showed slightly positive skewness, meaning the scores were slightly put toward the higher ends. This suggests a slight tendency for higher score to occur, but the data remains relatively balanced. To visualize the distribution of score, I created a histogram which clearly showed the range and frequency of score. Additionally, I created a pie chart to compare the proportion of scores between male and females. These visualizations highlight the general performance trends in the dataset. Here I used a bar graph to display the year-wise comparison of favorite SAT math score for male and female. This visualization makes it easy to observe trend over years, such as gradual increase or decrease in score for both genders. Finally, I created frequency and cumulative frequency polygon to visualize the progression of score across intervals. These graphs help in understanding cumulative trends, such as how scores accumulated over specific ranges. Now that I have given you an overview of the statistical concept in my slides, let's dive into implementations. I will show you how I analyzed the dataset using Python in Google Collaboratory. Firstly, I imported different libraries such as pandas, numpy, matplotlib, and some functions from scipy library also. I then loaded the dataset from CSV file and displayed the first few rows to ensure it was imported correctly. You can see that column include the year and SAT math score for both male and female. Since the data was already clean, pre-processing was not compulsory. I just go for implementation of statistical concepts. Next, I calculated with key descriptive statistics such as mean, mode, median, and there are also many other concepts which I didn't discuss in the slides. You can see the variance, standard deviation, range, interquartile range, percentiles, geometric mean, harmonic mean, quartile deviation, mean deviation, quartile, decile, percentile, range, kurtosis, skewness using both Pearson method and Brownlee's formula. I calculated also the coefficient of range, coefficient of quartile deviation, and coefficient of variation, coefficient of standard deviation. I calculated the moments in it, and here is the result of both male and female ungrouped data. Here is the group data. First I converted both male and female columns into group data. Here is the result. I converted them into group data and later I applied statistical concept of group data formulas in them. I made sure all the concepts are covered for both ungrouped and there is no concept in descriptive statistic that is left over. Here is the result. The first one is for female student and the second for all the male students. This section of the code generates visualizations such as histogram, pie chart, bar graph, frequency, cumulative frequency, polygon. For example, you can see all the concept here. Here, see, this is the code of pie chart, and here is the results. This is my bar graph, pie chart, and all the concept I discussed above. And we have already seen the implementations. In conclusion, my analysis revealed that male scores were consistently higher than the female score throughout the years. However, the difference in score was not drastic and both distributions were slightly positively skewed. Data visualization further confirmed this pattern and provided additional insights. Overall, this project demonstrated how statistical techniques can be applied to real-world datasets to uncover meaningful trends. Thank you.